I care? Why do I gotta learn this? Why is it important to communicate motion? Well, if I told you I buried $10 million in a chest nearby, could you find the money? Now, if I told you you had to drive 2 miles to get the money. Whoops! I meant to drive 2 miles from the front door of the school to get the money. Still, not really great directions. Maybe if I said the center of the chest is exactly 947.32 meters from the school's flagpole. Could you find the money? No. Now, if you're stopped by a police officer and the officer says you're going too fast, and you say, well, how fast was I going? How fast is too fast? And he says, yeah, too fast is too fast, and you were going too fast. How do we communicate how fast is too fast? How do we determine whether someone is going too fast or not? Next, you get a notification on your phone saying there's a tornado. What do you want to know about that tornado in order to determine whether or not you should take cover? Probably need to know things like, where is the tornado? How far away is it? Is it heading towards me, or is it going away from me? So we need a common language to discuss things, and physics is about 2 things: determining what happened and being able to communicate what happened. That last little part there, being able to communicate, is the problem is the biggest struggle I see with students. So remember, as you go through this course, you really need to think about what's happening or what happened, and then use your words to explain your thought process, how you came to that conclusion. Next, in physics, we predict what's going to be happen, and being able to communicate what will happen. So if we make a prediction that 2 cars are going to crash based on the speed that one's going and then the speed another's going, well, we have to be able to explain precisely what our thought process was to get us there, and that will allow us to come up with a really good prediction that gives us a lot more information. The key that we need to be able to understand is that we need to be able to understand something and then be able to communicate. For me, I struggle communicating on these videos, but if I'm explaining a physics problem, it goes a lot smoother. It's less improvisation, and more understanding the process and getting my thoughts out rather than going through a PowerPoint. To understand, we need to be able to put our words to our thoughts. To communicate, we need a common language that we all understand. And we have 2 types of quantities that we're going to be using in physics for the whole rest of the year. We have vectors and scalars. In physics, we use quantities, or measurable numbers, as part of our communication. If we go back to that hypothetical situation and think about how easier it would be if the officer specified the speed that we were going, or we had a direction for the flagpole. Rather than 947.32 meters, it was 947.32 meters east. So if we're a little bit more careful in our explanation of our quantities, then we can communicate better. Notice sometimes it helps to know the direction of something, other times the direction is meaningless. We don't need to know what direction we were going when we got pulled over, we just know we were going too fast. 2 types of quantities. Again, we have the scalar, which is a quantity that only has magnitude, and magnitude is a fancy word for amount. There's no equation you need to know for magnitude, it's just telling you how much. So if we're asked to find the magnitude of acceleration, then we're just figuring out the acceleration. We don't need to worry about direction, it's just how much. Scalar is just a number. Vector is a quantity that has magnitude and direction. And translation, a vector is a number that points somewhere. So if we said our acceleration was 3 meters per second squared, that is a scalar. If we said it was 3 meters per second squared up, down, left, right, east, west, north, south, positive, negative, any of those directional indicators will turn that into a vector.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Some examples of vectors is a position, straight line distance from point of origin to where an object is. We have displacement, straight line distance from one point to another. So position, displacement. Wouldn't it have been easier to find the money if you knew the straight line distance from the origin to the flagpole and had a precise direction to travel? We have velocity, which is speed and direction. Wouldn't it be nice to know the tornado's displacement from you, the straight line distance from you to the tornado with a precise direction, and the tornado's velocity, the speed with direction, to see if the tornado is moving towards you or away from you? Also tells you how long it will be before the tornado arrives. Another vector we're going to learn about is force. You remember force from middle school, junior high, as being a push or a pull. Force has a magnitude, which is a number that determines how strong the push or pull is, and a direction, which direction the object is being pushed or pulled. Can you push something up, pull something down, push something north, south? Absolutely. Another vector we're going to learn about is the gravitational field. Gravitational field has a magnitude, which is a number that determines how strong the gravity is, because gravity is not the same everywhere, and the direction, where gravity is pulling things. You get one guess in the direction the gravitational field you're in. Some examples of scalars. Energy. Energy is just an amount that an object has or gains or loses. You would never say, "What a workout. I burned 1,000 eastward calories." Temperature? Brr, it's 40 downward Fahrenheit degrees outside. Putting direction with temperature just doesn't make sense. Time? It's going to take me 2 hours north by northwest to fix your air conditioner. Direction just doesn't make sense. So sometimes it's important to use a vector. Sometimes it's important to use a scalar. Money. Got $20 in my pocket. Don't give me 15 to the right. I'll only have 5 to the right in my pocket. Idiot. Here's a summary. Vectors have direction. Scalars have no direction.